Question 1.3.2 reads, for which value of p will f of x is equals to p have two unequal negative roots, right? So in your answer sheet, you have 4 ways of doing it. I'm going to go through 2 ways of doing it. We're going to do it graphically and we're going to do it algebraically. So let's think about it graphically. This is what our graph looks like, well, for now. Okay, that's supposed to be touching, so let's just take it down a little bit. Okay. So our graph is cutting our y-axis at 60 and our x-axis at 40. Now, in order for us to have a graph that has 2 negative roots, this graph needs to go down a little, right? So it needs to go just down a little, right? And we can see what is changing is our y-intercept. So let's then look at the equation of our graph. It says f of x is equals to x squared plus 8x plus 16. And now it should be equal to p. Now we know that to find our y or our x-intercept, we would have to make f of x equals to 0. And we can do that by taking x to the other side. So we'll have x squared plus 8x plus 16 minus p is equals to 0. Now, in order for this to have 2 negative roots, our intercept, our c, needs to be lower than 16, right? Our c needs to be lower than 16 and also needs to be higher than 0, because let's look at when it's equals to 0. So let's say our intercept as a whole is equals to 0. What's going to happen to our graph is that it's going to go down so low that it only cuts this part and that part, and that's not part of the restrictions that they've given us. They don't want it to be equal to 0. They want it to be equal to a negative value. So we don't want that. So we have 2 restrictions. It cannot be equal to 16 or greater than 16, because if it is at 16, it only has 1 negative. And if it's above it, it doesn't touch the x-axis at all, right? And then we take it with regards to taking the graph down. Now, when we take the graph down, it will have it gets to a point where we have one of the factors being equal to 0. We do not want that. And if you take it down further than 0, again, you're going to have positive factors, and you do not want that. So you can clearly see how your intercept has to be between the values of 0 and 16, right? So that means 16 minus p needs to be in between 0 and 16. Okay, so now let's solve for this. So here, as I'm continuing on, we have the first method that they use by just looking at the graph and making those assumptions, and we kind of incorporating the second method so that it's more clearer. The second method that they have underneath the graph there, if you look at your answer sheet. So what we're going to do, we're going to take 16 to the other side. We will have negative 16 on this side, and we will have 0 on that side. If I go ahead and divide by negative 1 everywhere, my signs are going to change. I'll have 16 like that, which is basically the same thing if you turn it around. Do it like this. So this is exactly like that. They just prefer to write it in that manner. And we can see how p needs to be in between. So it cannot be equal to 0, nor can it be equal to 16. But if it's in between, then we will get 2 unequal negative roots. Now, another way to look at it is to look at the nature of your graph, right? The nature of your factors, I mean to say. So we have f of x is equals to x squared plus 8x plus 16 minus p. Now, the nature of our roots is determined by the determinant. The determinant is given by the equation b squared 4ac. You might remember a little bit about this. So our determinant is going to be 8 squared minus 4. Our A is just going to be 1, and our C is 16 minus. Right? Then here we would have 64 minus 4, 16 minus P, and go ahead and multiply out with that 4. So we have 64, 4 multiplied by 16 gives us 64 plus 4p, and we will get that our determinant is 4p. Now, in order for our determinant to have real and unequal root, our determinant needs to be greater than 0 to have real and also unequal. Our determinant needs to be greater than 0. So it just basically means that 4p needs to be greater than 0. So therefore we can say p needs to be greater than 0. We know that. Right. Now we have to put in another construct to say, okay, we have it now as unequal and also real, but how do we get the roots to both be negative, right? So now if we look at the quadratic equation, let's write out our quadratic equation. We say that x is equals to negative b plus minus the square root of b squared minus 4ac, right? You would see that 4ac here in that bracket there. Sorry, the square root is our determinant, so we will have that as minus 8 plus minus the square root of 4p, and everything would be over 2. Now, in order for you to have a factor that is going to be a negative, you are in a sense kind of constricted by what is happening in your numerator, right?
Recording in progress.
In order for your numerator to always be a negative, the square root of 4p must always be less than 8, right? If it's less than 8, you will always get a negative value there. So let's solve for that. Let's go ahead and square both sides by 2. We get 4p is equals to, less than 64. We will divide both sides by 4. We will get p is less than 16. So here we came up with 2 conditions to ensure that not only do we have a real and unequal solution, but we also have a negative one. So here we needed to make sure that it was negative. We came up with 2 conditions that p must be greater than 0, but it must be less than 16. Again, you can write it like this, which is the same as we got for our first one.